Are you ready for an awesome event that you'll remember your whole life? On August 21st, 2017, the first total eclipse of the sun in 40 years will cross the U.S. In a band 70 miles wide stretching from Oregon to South Carolina, the moon will completely block the sun. There'll be pink flames around the edge. Big silver streamers of the sun's corona will cross the sky. People will scream and cry and shout. Animals will do strange things. Only when the last little sliver of the sun's visible surface is completely covered by the moon can you take off the dark eclipse watching glasses and with just your eyes watch the spectacular total eclipse of the sun.
It's getting dark now, man.
The rest of the United States will see 80 or 90% of the sun covered. You might think that 80 or 90% you'd see most of the show, but you'd be wrong. A total eclipse of the sun is the part you'll remember your whole life, and so if you get the chance, travel to where the eclipse is total. Here's what it'll be like on eclipse day. You're waiting and waiting until finally the moon takes a tiny bite out of the edge of the sun. It'll take more than an hour for the moon to slowly move in front of the sun. And as long as even a sliver of the visible surface of the sun is not covered by the moon, you've got to protect your eyes. These are not sunglasses. They're more than 1,000 times darker, and they're made specially for looking at the sun. If you can get a pair of tested and certified eclipse watching glasses, do it. If you can't, make a little hole in a piece of paper and hold a second piece of paper 2 or 3 feet away, and you'll see projected a tiny image of a partial eclipse. The total part of the eclipse lasts a little over 2 minutes, and that will be the shortest 2 minutes of your life. Totality ends when a tiny bit of sun reappears, and it looks just like a diamond ring shining at the edge of the moon with a little round circle of light.
Here it comes, diamond ring. Oh, you won't believe the view in here. You won't believe how beautiful this is.
When the diamond ring happens, that's when you have to stop watching with just your eyes. Protect your eyes with the eclipse watching glasses.
Everyone in North America is going to experience at least a partial eclipse. And that total eclipse in that 70-mile wide path is going to be somewhere between 30 seconds to up to 1 minute and 40 seconds, depending on where you are. The closer you are to the center of that line, the longer you will see the total eclipse. But the partial eclipse is going to be more on the order of 2 to 2.5 or more hours. And so that's an event that everyone is going to get to experience for a long period of time. So we're going to talk about that. Right now you're seeing a map that's showing you this path of totality. So this is this patch where the moon's shadow is going to be cast across the United States. In that path, you're going to be standing in the shadow of the moon. And so now we're going to switch to an animation to show you not only the path of totality, but also you'll see these yellow circles that are going to show you the progression of the partial eclipse across the continental U.S. So you see as it gets closer to totality, the sun is eaten away by the moon, and then you see the sliver disappear, and those in that path are going to see this spectacular corona. And then everywhere else in the United States, we're going to get to experience a partial eclipse. So I hope everyone got to listen to the public service announcement by Doug Duncan, just to give you kind of a flavor of what folks are going to get to experience. And while not everyone can be in the path of totality, everyone is going to get to experience this eclipse in some form or another. And so now the next question is, well, what exactly is an eclipse? So quite simply, the moon comes between the sun and the earth. The moon is in the right position, the right distance between those two objects, and it's aligned in the right plane between those two objects only at certain times. And because of that, you get this shadow cast down on the earth. You have an area around that shadow. That shadow is called the umbra, and outside of that shadow, called the penumbra, is where you experience the partial eclipse. Inside of it is where you experience the total eclipse, and you get to see this fainter outer atmosphere, millions of times dimmer than the bright solar disk. The bright sun is what we call the photosphere, often called the visible surface of the sun. And that light is incredibly intense, so intense that even when 99% of the sun's disk is blocked out by the moon, you still can't see that faint corona. So this next slide, you're seeing two different perspectives. One on the left is a real image. This is an image from the International Space Station. You're seeing that shadow cast down on the Earth. That's the spot that you would be inside of if you were in the path of totality. And on the right, you're seeing a snapshot of one of the animations that NASA has created at its Scientific Visualization Studio that's showing you perspective, the side view of the moon casting its shadow down on the Earth. Now, this next image, this image is a photograph in visible light, a digital photograph, showing you the corona when the moon has blocked the sun out. Now, I want to tell you a little bit about it. This is not exactly what you would see, but it's pretty close. Now, actually, our eyes are such good photographic instruments. Our eyes are able to see dynamic range, a range of intensities, so much better than a digital image. So this digital image is actually many digital images, somewhere between 20 and 30, placed on top of each other. But if you look at the eclipse in the sky during totality, it's going to be much smaller. But if you zoom in with the binoculars, and I will emphasize, the only time it's safe to look at the sun is during totality. But during that time, if you looked with a binocular or a telescope without any sort of filters in visible light, this is pretty close to what you would see. Now, I'm going to go to the next image, which is going to give you some of the details of what's actually in this digital image that you see. Now, up on the left, on the edge of the moon, you see these red structures. That is the lower part of the sun's atmosphere called the chromosphere that is supported up into the corona being this outer atmosphere of the sun. And this structure is much cooler, much denser, and you're able to see these objects called prominences. And I'll show you shortly a real image of a prominence directly. But you see these prominences. These things can sometimes erupt from the sun. You see all of this structure. You see plumes coming out of the poles of the sun. This is hot solar material that is following the magnetic fields of the sun. And basically what I wanted to point out is all of that structure that you see, the loops, the streams coming out, that kind of almost ethereal spider web is created by the magnetic field of the sun. The sun is a magnetic star. It's a dynamic star. And the reason that it's so important and so exciting for scientists to look at the sun during an eclipse is this region we see here is very difficult to study, even from space, especially in visible and infrared light. And in fact, we can't study it at all from space. And it's very difficult to study at any other time except during the total solar eclipse. And why is that important? Because that's where all the action is happening. All of those magnetic fields contain energy. And just like having a rubber band that you twist and twist until it eventually snaps, releasing that energy you've built up as you twisted it, these magnetic fields do the same thing. And when they release that energy, we get huge, huge releases of material, and we also get massive amounts of light through the entire electromagnetic spectrum. And this image that you're looking at now is one of these prominences that it actually has started to erupt from the sun, and it's huge. Going from one side to the other is something on the order of 30 to 40 Earths side by side. So this is a massive structure, hundreds of thousands of kilometers in size. And this object leaves the sun at speeds of many millions of miles per hour, and that solar material and magnetic field that's carried away. We call that a coronal mass ejection. And then you have this huge flash of light, and that's called a solar flare. And these are two types of space weather. This energy and this material travels through the solar system. It can reach Earth. It can disrupt our communications, our satellites, GPS. It can even disrupt power grids on the ground. And it creates the aurora. That's actually the visible manifestation of that. But this stuff also travels through space. It impacts our spacecraft. It's important because all of this material can be dangerous to astronauts in space and ultimately to an astronaut that someday will be traveling to Mars. There's even more aspects that are important for understanding other star systems and the formation of life itself. So what's happening on our star and what's happening on other stars, because studying our star tells us about all the other stars in the universe. One thing I like to remind people, you look at these beautiful images from the sun, so you see these, and every time you look up in the sky at night and you see a star, you're looking at one of these objects. But we can look at it up close. So we're going to go to a video that's produced. The image that you just saw was from the Solar Dynamics Observatory showing us extreme ultraviolet light from space. We're going to show you a montage video to show you some of this activity that I've been talking about. So all of this data comes from the Solar Dynamics Observatory, or SDO. This is from one particular year. It's been up since 2010. So there's the extreme ultraviolet sun. You see those giant loops. Those are loops that are highlighting the magnetic fields. Magnetic fields, of course, are invisible, but the sun's material traces out those magnetic fields. There are those prominences that you see during a total solar eclipse. That structure you see is what you can see during a total solar eclipse. And eventually those structures can become unstable and erupt. So now we're looking at an eruption that's just about to happen on the sun. There goes material flying off. You see even those loops wiggle as stuff is leaving the sun. There's another eruption happening. Those are giant loops of magnetic field and material that are coming out of sunspots. And there is a flash. That is a solar flare. Enough energy released to power the entire world for 100,000 years. And here is a close-up of one of these regions just over a sunspot. And then there's an eruption. Some people call those solar tornadoes. And there is the eruption that we showed you the still of. So that is billions of tons of solar material flying away, and when that is facing Earth, it comes to us and interacts with our magnetic field, creating geomagnetic storms here on Earth. This is the foundation of space weather, and all of this activity is happening in the corona. So looking at the lower corona during a total solar eclipse is a unique time that we can see these sunspots manifesting and releasing their energy high up in the atmosphere of the sun. So that is what is so important about looking at the sun during a total solar eclipse. So that's the science. But right there you can actually see the huge eruption and all these magnetic fields wiggling on the sun. So this is the reason why we want to study the sun. Actually, right there you're seeing Venus moving in front of the sun. This was the transit of Venus in 2012. Here's another shot of that. This is actually interesting because an eclipse is a type of transit. That's a transit. That's a planet transiting the sun. That's actually how we find planets around other stars. It's a form of eclipse. So all of these images come from the Solar Dynamics Observatory, and actually all of them are available for you. This is one of my favorite ones.
You know, Alex, before seeing this today with you, I never realized you could see the raining back down of the material from the comet and stuff like that.
Yeah, that's one of my most favorite ones, is that you see these giant loops that are full of solar material, and then you can see that material streaming back down. We actually call that coronal rain. So the material gets hot, it rises up in the atmosphere, condenses, and flows back down. And it's one of the most spectacular sights. When I first saw it, I was completely blown away.